Last day of HIACON, 25th anniversary. My name is Rick Trojan, and I'm the Vice President of HIA Board. We have a great treat for you today in Track 7 Processing. We have Darwin Millard and Dan Gustafik, and they're going to talk about hemp processing at scale, the do's and don'ts. So let's hear it for these guys.
How's everybody doing today? Right after lunch, so hopefully everyone's all perked up and ready to learn stuff. Excellent. So thanks for the quick introductions there. I'm going to give another brief just kind of discussion of who we are, introduce Dan, who you'll soon learn is the man. And of course, we're going to, today what we're talking about is processing facilities and the do's and don'ts, the common mistakes that we see our clients make throughout industry and how these can detrimentally affect their projects. And then of course, identifying allowing you to see what these pitfalls are, and then go through what are the ways to prevent them from happening for your projects and make sure you actually get through permitting and can actually start processing all this hemp that you'd like to turn into CBD or whatever it is. So my name is Darwin Millard, and I'm a mechanical engineer by training. I specialize in mechanical and solvent-based extraction methodologies for isolating terpenolic secondary metabolites from botanicals, and I've been working in the cannabis space for the past 11 years, helping clients on every scale of extraction, from the benchtop of just a couple of grams all the way to the commercial scale with some of the largest projects I'm working with Dan and his team at Hypertech, of doing 15 metric tons every 16 hours with the goal of producing around 10,000 kilos of CBD isolate every month. And with that, I've had the privilege of working with Dan and his team now for the past 5 years on several of those projects, both small and large. And I'll turn it over to him to introduce himself.
Hello, my name is Dan Gustafik, the founder of Hypertech. We're an architectural engineering company focused in cannabis and also hemp sector. We currently don't do anything else except for those two sectors. Used to do a little bit of controlled environment agriculture stuff, but that has kind of weaned off to focus mainly on these industries. Currently, we have about 140 completed projects and about almost 3 million square feet of actual complete facilities across the U.S. and Canada. We're licensed in 37 states and multiple countries, mainly Canada. We've got about 6 provinces up there. So with that, we're going to kind of move on to the common mistakes. So this is, and this may sound a little bit negative, this is something I've been talking about, the common mistakes, for a couple of years. This is something a lot of people are aware of that tends to be invaluable for a lot of people starting out in the sector. So we're going to cover just the general pitfalls, and then before your ears bleed about that part, we're then going to go over to Darwin to talk about how to do it correctly. So we're going to have a little kind of pass-off thing as we start talking. So the biggest thing that most people will be really aware of is the failure to budget being the #1 reason projects fail within the actual hemp extraction. And the main reason is a lot of people coming in the sector do not actually have an appropriate pro forma based upon the actual process required. They also normally don't have a property that's actually made that can take the process itself inside of itself. This is very common on exclusive farm use properties or TPZ zones, which are, well, different places have different zones than just timber production. That's one designation. So your state may have a different usage code for that type of property. Those properties generally have exempt structures with a lot lower cost. So right away, the failure to budget is there's a lot of intricacy into actually having an actual budget that appropriately reflects what needs to actually happen within an actual hemp extraction plant, especially at scale. The other thing, this is probably #2 item, is the lack of process train. So a lot of people we talk to, when they first come to us, they say, we have a great building with a steel, which is normally a red flag right there. We have an amazing process already done. We're doing it in insert name of state here, and we're going to do it in this state with maybe a little bit different permitting process. It's a very common request. What normally happens is we start working with that client. We find out very quickly they're missing certain items. So, and when I say certain items, I mean any item missing within the process train that is not an approved item with UL listing that, of course, actually has the ability to be installed in that part of the process, whether it be an ethanol process, a CO2 process, whatever the case might be. That is not going to actually make the project work. We're going to actually have a delay of sometimes up to 5 or 6 months while certain pieces are actually playing, we call it the round robin of equipment. It's very common.
And that's directly related to, say, some of these Chinese pieces of equipment that have been imported for hemp processing because they're quick and very easy to get, but they're not appropriately stamped or certified.
Yes, actually the Chinese equipment is actually a good call. Yeah, nice looking units too. Great units, 500 liter units, 300 liter units, fabulous units. No UL listing, no ETL listing, made in very quick fashion. Sounds fantastic to everyone, of course, who's looking at the dollars and cents portion. Sounds terrible when it comes to actually trying to install that piece of equipment when no inspector ever is going to allow that to be installed. So process train, probably number 2. The last one's pretty straightforward, but the lack of compliance. This one is just people trying to cut corners everywhere they can, which a lot of times is coming from the CFO or the budgeting, whoever the budgeting arm of the company is. We'll see a lot of cuts. Some of these are concise, some of these are just shotgun approach. These cuts can be drastic to functionality. Some of them can actually be catastrophic to the actual project in question. The lack of compliance, though, is a death sentence to the project. So it's one of those areas where you can't say, oh, we're not going to have the fire rating in this room, or, oh, we're not going to have the sprinkler density in this area, or, oh, we're not going to have classified areas, or, oh, we're just going to not talk about how we're doing the second or third part of the process. Let's talk about the main part. So those are the main kind of ones. We're going in the big overview here, but now we're going to go through a little bit more detailed. So the top 10 mistakes that we run into, the number 1, again, we've already talked about a little bit, is process train design should be done before you actually go basically any further. A lot of people want to talk about throughput, and Darwin will cover this in just a minute. That's fantastic. That should all be completely shaken out before you go into actually saying, we're now going to design a system for this building in particular. We're now taking this process train and putting it in. So number 1 is just not having that. Number 2 is a lot of people hire design professionals, and those professionals that are giving them information may give you information that doesn't sound good, not information they'd like to hear. So we have a lot of ex-clients mostly that were people who just did not like the information we're providing across the table. I give you some great example a little bit later. We have a couple of actual failures where we'll talk about where actual specific projects, thankfully no one's names because we're not going to defame anybody in this process. But yeah, that's probably one of the big ones is not listening to people. The other one is building absolutely anything. If you have anyone on your team who'd like to go into construction pre-permit, just take them aside and say, please don't do that. You'll create a two-founded problem. The number 1 is it's illegal. You're not supposed to be building outside a permit, so that's kind of a big one. The other one is the design professionals are now going to have to chase after you to find out what actually happened and if that was actually code compliant or if it even works in your plan. So very often people are saying, hey, I want to get a jump on this. I know you said it's a year until we're actually operational. That's just too long. The market's hot. We need to get in market right now. So very commonly that'll be a someone in the team's concept, and it tends to not go so well, especially if you get caught building outside of your permit. There's another part that happens there that I'll cover that a little bit later. Other one, you're not engaging the local community and permitting agency. This is a very common thing. People don't realize that you should actually reach out to your planning department right away. You should also reach out to your fire department right away. Like they'll say, oh God, I don't want to do that. It's going to open up a can of worms. Actually, no, it starts the process. You can actually talk to them about, this is what we're doing, this is how it looks, this is how we're complying with your local codes. Start getting a relationship and a comfort level with them.
And
The alternative.
My bad, Dan, sorry, but making sure you identify the appropriate person within your local agency to talk to as well, because there could be varying opinions about sprinkler density, for instance, and if you don't go to the appropriate inspector, you could be getting the wrong information.
And the other thing is also, there is normally some sort of early assistance meeting available. This is actually a great time for you to sit down with the people who are actually going to be handing out your permit and talk about your actual project. Most jurisdictions have this. It's going to cost you normally less than $2,000, which may sound like a lot to some people. It is not. It's a godsend. You get to sit down and say, this is my general rudimentary plan. Here is all the stakeholders who are going to be reviewing my plan. What do you think about it? Give us some feedback and then say, great, how can we come into compliance with what you'd like to see? This saves you an enormous amount of money, and a lot of people don't realize that's the way to start the project versus the inverse is when you're saying, hey, I want to talk about my lawyers. Just be aware that the county and the city, the minute you're going there, you're normally going to have a problem with your project. which I know there's lots of lawyers in the industry, so I'm not trying to say anything bad about lawyers. Lawyers are fabulous, but when it comes to the city, that's normally the wrong approach. They're not frightened by that. In fact, that normally has the opposite effect you'd have or you want desired. All right, so last couple ones I want to kind of burn through real quick. Misallocating funds is pretty straightforward. Hiring the wrong GC, it really is a matter of finding a general contractor who's built anything resembling a processing facility. So really, beer is a great example. Kombucha, it's very similar. Wine, great concept. Anything where you have some sort of pressure vessels and some sort of process occurring and a lot of process piping. So very heavy MEP and mechanical, electrical, plumbing capabilities. This is what you're looking for. What you're not looking for is someone who's built a lot of apartment complexes who gives you a great price. That project is going to go to hell fast. So micromanaging design engineering teams, this is really more about the process train individual. We've had this happen before where sometimes they are hiring a process train expert, PhD level or non, someone who knows what they're doing about the process, and then their own internal team who was obviously not going to say anything about their capabilities, not listening to that individual's acumen, creates some problems in the process. We've normally had things go wrong, and I don't need to go down that road deeper, but yes, generally don't micromanage the actual design team in that regard.
It also happens when the, say, investors in the project think they know more about extraction than the consultants they've hired.
Actually, that's probably the number, I'm really glad you mentioned, that's like the number one that always happens is, you know, do you really need that piece of equipment? And you're like, it's critical to your entire process to get you the output you want for whatever end product you have. And they're like, is there another piece that's cheaper? Like, well, we would have put that in if that wasn't the case. I mean, that's a very common, I've heard him arguing this one before, at least. All right, so the last two here, negative interactions with local and inspectors. Can't stress this enough. You're starting out in a power imbalance. And as long as everyone can accept being in a power imbalance, you'll be healthier and happier. Be aware that your inspectors have the ability to take a combination of, you know, a couple 100 pounds of code books and throw them on your head. So if they're showing up and they're happy and you're saying, I'm going to do everything you'd like to see and I want to do it as well as you'd like to see it, you're creating the right kind of relationship. If you're saying, hey, you're going to permit me right now, or I'm going to stick my lawyers on you, you're creating the wrong type of relationship. You will have a very distinctly different cost output and time output should you start on either one of those paths. We always say start on the right path, which is they're the ones who are giving you the permit. You're the one who's basically saying, we'd like to make it compliant, make you happy. That one could even probably move up more, but whatever. This is not like an actual list of things that in order. So number 10, not being responsive. If the jurisdiction has a request in permitting that says, hey, we'd like to find out what your SOP for this part of your process is, and you didn't give them the full, complete answer, say, absolutely, we'd love to give you that, and of course, take the time it needs to actually give them that sequence of operations. They have to see that. They don't really care about your process. There's no IP being stolen by plans reviewers. That's not happening. They're really wanting to find out, where does 150 gallons of ethanol go? Where is it sitting? Is it sitting there? Does it sit over there? And then from there, where does it go to the next place? Does it double? Where does the 300 gallons go? It's more along the lines of finding out where the things that basically explode and are, of course, reviewed by the plan examiners are moving, and normally where they're stuck. The most important thing is where is it 90% of the time? That's really what they care about. Moving, not as critical as long as it's, of course, not just getting poured in open vessels over here, you know.
So the next one is, these are a couple examples of failures that we've experienced. And before I let Dan go into some great examples, just one just recently that I was working on in regards to a major hemp processor. Ran into both issues, 10, 9, and 3. Going ahead, being the owner of the project, very involved in architecture and real estate projects, thought he knew how to build the buildings, went ahead and started building things, and got into a really bad relationship with their local permitting authority, and now essentially are in the process of needing to find a GC to actually take on the liability of their building that they went ahead and built without permitting in order to move the project further on. So they're kind of now stuck and can't go any further with their project or produce any product until they can find a contractor who can essentially take on the liability and the assurance behind their facility to make it comfortable for the local commissioning office to be able to allow that business to operate.
And then these other examples, I'll kind of run through these quickly because I don't want to hammer this home too much. This tends to be like too much hammering on the negative is just, it's like getting pounded on the head. So I don't want to run too much on that. So we've removed company names, of course, because that would be terrible if we put them up here. So one company we know of, which of course these are all, by the way, I should clarify, these are all projects that we were involved of that of course did not go so well. They had a proprietary method with very little feedback and input from any professionals that they had made themselves that had some supposed amazing output. There was no third-party verification of this amazing thing. Nothing happened. Long story short, it didn't actually work, and they ended up, of course, having to liquidate because their pro forma was light years away from the reality. So, pretty straightforward. Another company Y, we have is a really well-known name that we're not going to put up there, the cannabis and hemp cultivation. They basically wanted to go into extracts to become vertically integrated, which sounds glorious. At the process of doing that, though, they ended up having quite a few issues along the ways. Basically, yes, the YouTube clip is actual reality. They found the extraction equipment by looking on YouTube, which is just not advisable. They then purchased the equipment after a quick walk through the facility, and they then had multiple units, actually 3 to be exact, that were nowhere near being able to be installed. They also had no post-process definition, which is basically just bulk CO2 extraction, and then magic happens, and it gets in some sort of final vessel. So again, just 2 quick examples. These ones also, again, 2 companies as well. Company A, founded, very interesting founder, basically had absolutely no idea how to legally process anything. They were used to the quasi-gray hemp market, which is a unique market that I think a lot of people should, if you don't already aware of, exist. You should be aware of exist. You're able to get away with quite a bit by having facilities on ag-exempt properties that are not inspected by anyone. Sounds glorious until, of course, the fire marshal at some point finds out about it. Radical changes, they spent a lot of money, delayed by, that says weeks, but it was technically actually months. The other company basically had a partner with very little funding. Actually, that last one's very sad. To this day, the facility is actually full of equipment. So they have a project, and the entire place is completely loaded out with, classified rooms. The extraction vessels are there. The chillers are there. The boilers, the Haskell pumps, all the great accoutrements are sitting there, but they're lacking the last 500 to mil, whatever it's required to push the thing over. And it's been like that for, I think, about 8 months. It's also in a state, unfortunately, with a massive boon of harvest, so it's kind of terrible. But yes, those are the main failing ones. Let's move on from those.
Yeah, so obviously we've been hitting a lot of things home here that with failures can come of delays to your project, and of course in the hemp space where being first to market or at least next to market as soon as possible when demand right now is so hot is critical to ensuring that you can get your brand established. So how do we avoid some of these pitfalls? How do we make sure our processing facilities actually get operational? Well, first and foremost, which we're going to be hitting home on here a couple more and more, is the fact that you need to define the process train first. You have to do that, and all of the various elements have to be known before you can go into the next stage, which is, okay, where am I going to put all of this equipment? And one of those major things, of course, when you're designing a system to say that deals with 15,000 gallons of ethanol, or potentially several thousand liters of CO2, or whatever the volume is that you need to process your capacity for your day, or whatever it is, how are you dealing with all of those volatile organic constituents? There are several fire codes involved there in regards to both exhaust and the sprinklers that have to be put into place. And when you're designing these facilities, it's critical that you hire a team such as HyperTech or others that are fully versed in the fire codes and building codes of your area as well as internationally, and can actually design a facility that's compliant. And then when you go to build that, you need to ensure your contractors have actually built these things before. Like Dan had said, if they haven't built a volatile organic compound exhaust system, then they're not going to know that everything needs to be leak proof, and potentially there may be a spark, and your system might have been compliant on paper, but because it wasn't installed correctly, now you've got a problem. And of course, needing to understand things like CO2 is a dense gas, so it's going to sink to the floor. And knowing where you need to install your exhaust points to be able to make sure you're not going to asphyxiate your crew if the worst case scenario ever were to occur. Of course, being right along with that is knowing your building and fire codes and the electrical codes, of course. These are going to make or break your project. Whether or not you had the correct room classifications when that fire inspector does come in is going to be really important, especially also making sure the equipment that's in that space was properly classified to be in that area as well. And of course, compliance is key, as we've been hitting. You need to be on top of these regulations in an industry such as hemp, when things are changing every day. We're not nationally legal yet, but tomorrow we could be, hopefully, with the 2018 Farm Bill when that goes through. Not tomorrow, but obviously very soon when it does happen. That's going to make us now compliant with federal regulations, not just state. So being on top of all of those is going to be critical to the success of your business. So little things here. This is an example of what not to do. This is a great CO2 extraction system here, but there are a couple of major mistakes that were made, such as using some of the standard porous foam, what are they called?
Acoustic tile.
Acoustic tiles.
Probably the most porous. In fact, it's designed to actually catch acoustic waves. It's one of the most porous substances in existence. Yeah, it's probably the easiest way to get your building to not be GMP is having something like that. Certainly not wash down ready, that's for damn sure.
Right, so when you need a facility to be cleanable, of course, now you have these very porous panels that collect dust and, of course, aren't sealed, so your sealing is dropping contaminants onto your product all the time. And then little things such as not sealing the floors or the copings along the walls, so you're not actually able to clean this space. So the system itself is awesome, but the space in which it is placed in is not quite so much. So from here on out, we're going to talk about how the do's, how the ways to make sure that your facility can be designed correctly and you can get through the permitting process and get your processing that first several metric tons of plant material into CBD extract. Dan's going to quickly go over the 10 successful elements of processing facilities.
So this is kind of, go to spin to the positive now. So the best projects we've ever been on involve a client who really understands hiring someone like Darwin or any one of the other process-trained experts to come in before you start blowing a bunch of money on architectural engineering design. Because really, the most important part is always implementing the process-trained your design. That's it. So until you have the process-trained design done, then you can implement it into the actual building itself. Until you have it completed, though, there's really no point in doing your programming. Your throughputs, everything's going to be off, all the calculations until the process train is defined. So that's definitely number one. Number two, manufacturers with UL, ETL, C1, D1, C1, D2, just manufacturers who have the rating you need for that piece of equipment. We can't use equipment that doesn't have the right rating. Sometimes we can get away with using mitigation methods like hoods, other things that basically cost you more money. We can do that, sure. But then you end up with a ducting run from hell when you have 12 hoods in a facility, which, why would you do that? You also, of course, have spent a lot of money on laminar flow hoods. Again, there's methods for mitigating the rating, but in general, if equipment doesn't have ETL or UL, you just can't install it. And unfortunately, the industry is plagued currently with equipment that doesn't have it. So what would be ideal, and these are why these are number 1, 2, is number 1 starts off first. Number 2 is right after number 1. It would be great before the project started if the entire process stream was defined and cut sheets were in hand. That would be miraculous. Then you'd have everything done. Now you can actually implement exactly these systems, which is what required for plan review. These reviewers require a cut sheet for every item. So anyone who thinks you can put in anything in your facility that doesn't have a cut sheet, that's not correct. You have to have a cut sheet for everything, including that tabletop unit you have plugging in. They literally want to see it all. Unless, of course, you want to pretend you don't have it, which is a whole other ballgame of, again, fire marshal, rolling the dice, hoping they don't see it. Number 3 is pretty straightforward. You need architectural engineers who actually know something about extraction. Number 4 is presenting your project to the authority having jurisdiction. So I mentioned this earlier. Every time you go in for a pre-planning meeting, you have a different tone right off the bat. You now are saying, how can we, again, help you to understand our product better so it can meet the current codes? That's the right foot, and a lot of them are also just scared. Like we had a Colorado group that literally said, we're not going to kick it up to state review, which is normal, even though it's 2 tons a day, because we're comfortable with the way you're presenting the project, which is phenomenal. But by state review, by the way, takes an extra 4 to 6 weeks on average, so let me backpedal. The reason why you'd like to not be in state review is because of that time you're going to lose forever. There's really no recovering that. If you don't have a state review and you're comfortable doing it with a local fire marshal, at that point you now can hopefully get approval and get the project pushed forward. Cost estimating company. Oh, I love this one. So no one realizes this, but there's these really fabulous companies that do cost estimating for you. Lots of them, and they're incredibly good at what they do. They don't just use RS means. They actually go through the entire, are you using union labor? Are you using standard labor? What kind of actual assemblies do your facility have? What kind of wall compositions? How many doors? They will actually go granular through your entire general plan and give you an estimate. If you have an estimate, your pro forma will now be far more accurate. So estimating companies are able to create a very accurate budget, and that will allow you to actually, of course, have the pro forma that matches that, which ideally has the amount of money that you need raised appropriately so that, again, the project doesn't fail. All right, writing SOPs from the beginning. This one's pretty straightforward. You have the SOPs written in advance. You will have a great, fast time when the plans examiners ask for them. You also now know what's about to happen. You know what your team's going to do. You know exactly what you can have them perform as far as the operations. It's fundamental in nature, it sounds like, but really a lot of people don't understand that I have this machine here, and I need to write a process for using this machine in my facility. Next to it, I have another, either pressure vessel, holding vessel, buffer tank, or another piece of equipment, depending upon the liter per hour flow rate between the two. And I need to do the exact same thing. How do I use this item? You have to do it for every single item when it comes to your sequence of operations. Everyone legally must have an actual manual. That's part of your process. Also, if you don't have a manual, you're going to have some problems with consistency and training. But the plan examiner is going to ask you for that. So if you write that way back when, you'll be set. It's one of those things that we wish everyone would do earlier on.
It's one of those documents that can be added to the support or the supporting document set during plans review, so that way if they have a question, we can go, oh, it was provided on this page, and they can actually look and then see the process.
And then the last, number 7, I'll run through these pretty quickly. Basically, when you filed your set for plans review is the perfect time to get 3 quotes for it. So a lot of people will forget that phase. It's a great thing to do. The minute you actually have your set done is now time to start getting some quotes, getting your contractors lined up, finding out if they can do the work, if they can schedule it, what their cost is, what kind of contract you're going to get from your contractors. All that can be done right away, and that's really good for when you get your approval. You now, of course, are ready to go. You picked the GC. You've got everything set up. Number 9, of course, after you're getting it, you're going to hire a contractor and start building with a third-party project manager. Why did we say third-party project manager? All too often, we have really, really great clients with really good people who have amazing capabilities. None of them are professional project managers. They're musicians or they're whatever their background might be, and they've obviously come into the hemp sector and maybe they're phenomenal at doing extraction, not project management. If you get a project management company, their whole entire job is to take and they're third parties. They're not connected to the contractor. They're obviously hired by you. Their whole job is to make sure the entire project plan, Gantt chart, timeline, of course, is met. That's it. They're going to make sure everything happens. They're going to make sure everyone's paid on time. They're going to make sure all the inspections are done on time. They can save your project 6 months. It's amazing. We've had projects get delayed because people didn't do that. They have issues with, this person wasn't paid or they weren't given the right work order. This group was not scheduled on time. The inspection wasn't done here. These effects just cascade and cascade and cascade to the point where you have massive cost overruns and delays. It actually saves you more money to pay one of these people. All right, last one is just taking occupancy of the building and completing your Department of Health or state licensing agency final inspection. That was just basically pretty straightforward, but a lot of people don't realize that they've got to first basically get occupancy and then do the DOH inspections.
So as we've kind of gone over the various elements that are behind a successful process train design, now that you understand that these are what's critical, let's go over some of the elements around process design. And specifically, this is where we would come in to help you guys really understand what it is you're trying to do. As a hemp processor, there are various different types of end goals now that you can do through extraction. Whether you're trying to make CBD isolate or THC-free distillate, or you're trying to make a full spectrum extract that's compliant, less than the 0.3% THC in the final material. These are the elements that we help you identify on the 30,000 foot view, and then start putting together and actually making the plan and identifying the actual pieces of equipment for Dan's team to be able to then put inside that facility. So when we are designing a processing facility, there are various different elements that we have to be looking into. What type of extraction is being done? What type of refinement processes want to be done? And are they going to be going, what type of separation and purification techniques are out there? There are several, but based on your scale and your throughput that you're looking to produce, can you actually get that with the types of systems that, say, you're looking into producing? And one key to note is that all of these process trains evolve over time. We're going to start with Plan A, but Plan A is only going to get better as we start working through the various nuances of that facility itself, or that exact process train. We may be able to identify several elements that can get you through, say, an investment ring or a round of trying to raise capital, but this isn't going to get you through permitting. So there's different levels of plans development that allow you to get through different stages of your plans. So what are the common elements that we find in extraction facilities? So regardless of scale, whether you're the very, very small and you're just starting out, or on the massive scale processing 15 metric tons every 16 hours, or some of the larger facilities I was talking to today, or not today, but over the course of HIA, some of the facilities doing 30 and 50 metric tons a day now, which is incredible, considering how small we were only in 2014. So 4 years for our industry to really grow domestically. That's amazing. But the common elements you're going to see, of course, are mills and grinders. You've got to take now all of this plant material and render it into something that's easier to actually extract. And once you've done that, now, of course, we actually have the extractors, whether it's ethanol or CO2 or some of the new water technologies that are being validated currently, or whether or not it's a hydrocarbon-based system. All of these need to be considered in regards to what is their throughput, how much are they, and what are the specifications or the certifications for those. Are they compliant? Are they UL listed? Are they ASME stamped? Are they actually safe for you to put into your facility? And once you've extracted that material, whether it's CO2 or ethanol based, you typically would go through, say, with CO2, a winterization process to remove all the fats and lipids and waxes, which are a typical contaminant. And if you're doing that, then you've got to filter out all those materials. Or if you did ethanol first, you might have several debris and other contaminants and things like that you want to remove. So you're going to use something like this large-scale plate and frame system that you see on the right here versus an benchtop filtration system like a Buchner funnel or anything like that, because you'll quickly determine that whether, while it's cheap and you can get some of these benchtop Buchner funnel setups, some is even as large as 24 inches in diameter, which sounds great. But it's very time-consuming and labor-intensive. And then you've quickly determined, well, this is an open solvent process, and it has to be a C1 Div 1 space for me to do all this filtration. And quickly, I should have spent the $100,000 on a plate and frame filter press instead of now having to rebuild my extraction facility. So of course, after you've filtered all the solution, everything's diluted in all this solvent, you've got to quickly remove all of that solvent. You've got to have to go through the desolvation process. So if you're using, say, a 15,000 gallon process, how are you getting through that in an economic time frame unless you're evaporating hundreds of gallons an hour? And being able to do that in a compliant manner and having your facility designed for that is critical. And then, of course, post-processing steps, everything from distillation, chromatography, separation and purification, and crystallization techniques. How do you do those with the appropriate equipment? And those are the things that we take into consideration when we are designing facilities. The very first elements we're going to take into consideration, right, is during that discovery and analysis phase. We're going to identify what are those elements we were talking about on the 30,000 foot level. We've got the major pieces. I want to do ethanol. Awesome, that's great. But what are the next steps? Are we doing what level of refinement are we taking that crude ethanol extraction to? Are we going through to a 99% or a 90% distillate, and from there precipitating out the crystals to make 99%? What's the end goal, essentially, to finding those various pieces? And from there, we're going to then actually do the design and engineering of each piece. So how much electricity, how much water uses the utilities consumption is going into the extraction train, the refinement process, the crystallization process. What is the consumables that are being used in that process, whether it's CO2 or ethanol? And then, of course, understanding what are the implications that has, such as the tax burden that ethanol has on manufacturers. And being able to then, of course, build in a reclamation cycle or a recycling process because you understand that ethanol is so expensive, we can't just process it through our facility. And then once we've actually identified all the costs involved in the process itself and the efficiencies and the engineering behind it, we then have to identify for Dan's team or others, what are the actual hazardous materials that are being used, such as an ethanol extraction facility. It's okay, well, what's the type of ethanol? Is it an open or closed process? Is it being stored? Is it process solvent? Is it being piped and pumped around the facility, or are we reeling drums of it from point A to point B? These are what allow us to build the appropriate supporting documents that Dan's team needs to get you through a successful permitting process. Then, of course, we're creating standard operating procedures in order to support and fully define the extraction or the entire process for the permitting review agencies. And to kind of bring it all together for you guys, we are a process train focused engineering group where we would specifically take our years of experience to allow you guys to more quickly get through what is typically a pitfall-ridden or hurdles-induced industry. And I think we're running a little bit out of time, so I want to quickly get through the last couple of slides so that you guys can ask questions too. But this is just a typical kind of linear thought process on how you design your extraction train. You need to understand the end goal. What are you making? Is it a whole plant extract? Do you want the acid forms or the neutral forms? Are we going all the way to pure CBD isolate? What chemicals are used in that process? Are they non-polar? Are they polar? Understanding the chemical properties, of course, allow you to design a more efficient extraction process. Knowing the solvent, am I using CO2? Am I using ethanol? Why? And what are the implications of using that much solvent, especially at the scale of operations? 15 metric tons every 16 hours uses a significant amount of solvent. So what are the economic and environmental impact that causes? All of these things are critical to identify for your zoning agency, your building contractors, and for the rest of the team in order to make sure that you guys can get a fully operational facility. This is just another quick example of a process train. This one was CO2 versus the other one was actually ethanol. This is just a quick example of kind of the evolution of a process train. One facility where I really liked having everything up in the dirtier portion of the building where we had this really nice 15,000 square foot area for receiving, but it didn't make any sense with the location of the solvent, so we had to move it. And then we also kind of going back and forth between, hey, it makes more sense to split all the solvent up into multiple tanks instead of one. And so we kind of come to our final decision on the design of our initial facility. And of course, this is just one example, and it has gone through many iterations past year. For everybody going through harvesting next year, a quick example of one of Dan's rapid drying facilities.
Sure. Actually, really fast as we're running out of time. All this is basically a temporary facility with a temporary service with a temporary system. So everything was set up in exactly 3 weeks. It does about 12,000 pounds of, terpene maintained product in 1 week. Obviously, if you want to change the terpene maintenance, there's a huge difference. The whole concept behind this, of course, is using large desiccant systems. And it was just novel in the fact that it went up in actually 3 weeks. After that was from design to delivery using plug-and-play temporary systems.
And this one was designed to maintain that terpene content versus you guys could design it to rapidly dry it as well.
Oh, yeah, well, that's easy. Yeah, so rapid drying is completely established and easy as hell, but maintain the terpene profile requires a certain level of heat be deployed basically very little.
Great, yeah. Thank you. Yes, you, sir.
That system is running 24 hours a day. But it technically has one loading cycle, and then it's left for the entire week. So realistically, it's a single, can't remember the hours, I think it was a 6-hour load-in, and then it holds for 7 days, and then, of course, there's a pull-down.
And the other question is, do you need different grinders that you're using ethanol or CO2, or you can use the same one?
You could use the same type of grinder. It's all about the particle size in that case and making sure you're finding the one that's good for your extraction system.
Great presentation.
Thank you.
I work with companies in Colorado, and one of the complaints that they have with processing is that Denver requires this excessive ventilation where you can't really even have corners in the room where you have any solvent during extraction. I was wondering if you think that that's accurate, and if you have companies that are doing extraction in Colorado.
We do. Corners of the room? Could you define corners of the room?
And by Colorado, I mean Denver, but like they said that it's very challenging to get airflow throughout 100% of the
Oh,
Yeah.
yes. So you have to meet, well, so it depends. It's either 1 cubic feet per minute for standard, or it's 3 cubic feet per minute for a vent. And that's required. So if you have facilities where you have material being stored in the corners, you will have a problem where you have to design an airflow system, actually almost identical to what's in this room currently, which is going to be a supply internal central and then return corners. It's very similar to server or clean rooms, clean room style, where the corners of the room actually are going to be the up, and then you're dropping cold in the center. You would be able to cover your corners. So it's really a ducting design issue, but they are correct. If the plan examiner, which Denver is notorious, wants to make sure that they're going to town with you, they will basically say you have to have 1 cubic feet per minute for the entire facility. And if you have, let's say, 200 gallons of ethanol stored in a corner, yes, that has to be 1 cubic feet per minute, or 3. So that it's alternating depending upon there's an event, 3 cubic feet per minute. During standard, it's 1. Yeah, that's just one example, but that's everywhere. That's not just Denver. That's a good example of where any code professional, basically, of course, someone who's representing International Fire Code, presents a requirement. They can present the entirety of the requirement, or they can present something less substantial. So remember that thing when I was talking about where you sit down and talk about and getting that comfort level? Every fire marshal in existence could take out the entire IFC and beat you to death with it. But if you are going to be nice to them and talk about how you're going to be safe and you're going to do all these things, very often there will be, you're not going to be held to the absolute letter of it. You will very often be able to find some method of equitable relief for the hazard being presented.
Thank you. That's super helpful.
Do we have one more? That's it. That's it.
Can we hear it for Darwin and Dan? Thank you.